Here we find the fifth degree Taylor polynomial for f of x equals sin x about x equals 0. So we are going to use this formula or the equation for the Taylor polynomial, that is Pn of x is given by f of a plus f prime of a times x minus a power 1 divided by 1 factorial plus f double prime of a times x minus a quantity square divided by 2 factorial plus f triple prime of a times x minus a cube by 3 factorial plus and so on. So we have to determine this, that is we have to find the derivatives, so that and then evaluate the derivative at a equal to 0. Here a equals 0, since we have to find about x equal to 0, and this means a is 0. So first let's find the first derivative, that is f prime of x, and this equals f of x equals sin x. The derivative of sin x is cosine x, so I write cosine x, and this implies we can find f prime of a, that is f prime of a is 0, so we find f prime of 0 by replacing x by 0 in cosine of x, so it becomes cosine 0 equal 0. And we could also find f of a by plugging in x equal to 0 into sine function. So this equals f of 0, and this equals sine 0 equals 0. I'm sorry, cos 0 is 1. So I put cosine 0 is 1 here. Now let's find the successive derivatives. So I'm going to keep on finding the derivatives, the second, third, and till fifth. So we get f double prime of x. This equals derivative of cosine x is negative sine x. So we find f second derivative at a equal to 0, that is f double prime of 0, by plugging in x equal to 0 into this one. So it becomes negative sine 0, and this equals 0. Now let's find the third derivative, f triple prime of x, and this equals we have negative sin x. Derivative of sin x is cosine x, so I put negative cosine x. We already have negative, so it is negative cosine x. Now we find f third derivative at 0 by replacing x by 0 in negative cosine x. So this becomes negative cosine 0. Cosine 0 is 1, so it is negative 1. Now let's find the two more derivatives. That is the fourth derivative of the function f of x. And this equals, we find the derivative of negative cosine x. So first I put the negative, and then derivative of cosine x is negative sine x. So this equals negative, negative is positive, so we get only sine x. Now we find the fourth derivative of the function at 0. So this equals, we have to replace x by 0 in sine x. So it is sine 0, and this equals 0. We now find one more derivative, that is the fifth derivative of the function f of x. This equals, we find the derivative of sine x, which is cosine of x. This implies we can find the fifth derivative of the function at 0. So this equals, we have to replace x by 0 here. So it is cosine 0 equals 1. So we find all the derivatives evaluated at a equal to 0. We can simply plug in into the Taylor polynomial equation. So I'm going to rewrite the Taylor polynomial. That is, we write sin x. This is approximately equal to, the first is f of a. That is, we can write down this as f of 0, plus the next term is f prime of a. That is f prime of 0 times x minus a is 0, so I put x minus 0 raised to the power of 1 divided by 1 factorial. We then write the second term, I'm sorry, this third term, that is f double prime of 0 times x minus 0 raised to the power of 2 divided by 2 factorial. We write three more terms, that is f third derivative of 0 times x minus 0 raised to the power of 3 divided by 3 factorial. plus f fourth derivative of 0 times x minus 0 raised to the power of 4 plus 4 factorial plus f fifth derivative of 0 times x minus 0 raised to the power of 5 divided by 5 factorial. We stop it here since we want to find only till fifth degree polynomial. So now we have to plug in all the values that we have found earlier. So let's look out for f of 0. F of 0 is 0. So I plug in 0 here. So this is 0 plus f prime of 0. F prime of 0 is 1. This is f prime of 0. So I put 1 times of, this is 1 times of x minus 0 is x. So it is x raised to the power of 1 divided by 1 factorial plus f double prime of 0. F double prime of 0 is 0. So I put 0 times of x minus 0 is x raised to the power of 2 divided by 2 factorial plus f triple prime of 0, that is the third derivative of 0 is negative 1. So I put negative 1 times of x minus 0 is x, and this raised to the power of 3 divided by 3 factorial plus f fourth derivative of 0 is 0. So I put 0 times of x minus 0 is x raised to the power of 4 divided by 4 factorial plus finally the fifth derivative of 0 is 1. So I put 1 here times of x minus 0 is x raised to the power of 5 divided by 5 factorial. We see that the multipliers with the 0, they become cancelled. So this is 0 and this is 0 and this is also 0. So finally we are left with only 3 expressions on the right side. That is, we write sine x, and this is approximately equal to the first term, that is 1 times of x power 1 is x raised divided by 1 factorial, which is 1. So we get x plus the next term is this term, that is x power 3 is x cube times negative 1. You can put this as negative. This is a negative quantity. So it is x cube divided by 3 factorial is 1 times 2 times 3, and this equals 6. So I put 6 plus this term is x power 5. So it is x power 5 divided by 5 factorial is 5 times, 4 times, 3 times, 2 times 1. 5 times 4 is 20, 20 times 3 is 60, 60 times 2 is 120. So this is 120. Now we got the expression for a sin x function using the fifth degree Taylor polynomial. So this is the expression, that is x minus x cubed by 6 plus x power 5 divided by 120. So using this, we are going to find the approximate value of sine of 1. So what we do is we replace x by 1 into this expression. So this gives 1 minus 1 cube divided by 6 plus 1 power 5 divided by 120. We know that 1 cube is 1. So I can just replace this as 1. Also 1 power 5 is 1. So it becomes 1. So therefore this is the approximate value or the expression which gives the approximate value of sine 1, which is 1 minus 1 by 6 plus 1 by 120.